Cloud would be provisioning n number of VMs. Yes, of course, it's going to provide huge amount of scalability and availability. The problem is the complexity of the applications, it keeps on increasing, and the number of dependent applications also keeps on increasing. So for every instance that is being provisioned, I may need to spend huge amount of time in doing the configuration, right from installing the dependent libraries, dependent software and the components. I may have to spend huge amount of time. So rather than doing that, what I can do, I can abstract those configurations and do that as a script. But again, I need to maintain the scripts dependencies, even though that is not required by the administrators or by the developers. If I can abstract that configurations and provide that as a single bundle with all the dependencies, that's where container orchestration comes into picture. And Docker is a very popular container orchestration. Let us see in detail about Docker. Assume I have Docker installed within a single host that would be running as a daemon. And there will be a registry, a common registry. Simple example, hub.docker.com. For example, hub.docker.com is a registry where it's going to have n number of images registered. We call that as a Docker images. With all the dependent libraries, for example, if I want to install or if I wanted to have, say, Angular, all the dependent libraries regarding the Angular will be built into it. In case if I wanted to have, say, Nginx, all the dependent libraries will be built within it. If I want to have Tomcat, Java, all the dependent libraries will be put in together as a single bundle, and that will be provisioned as a registry. We call that as a Docker registry. And Docker provides n number of APIs, where what I can do, I can operate against this particular daemon. It provides n number of commands, options, APIs, like build, I can create a new Docker image or pull a Docker image from the registry to the local system, or any image if I want to run, I can run. So lot other options it provides. So what happens, whatever the image that I am pulling it, that copy of the image will be stored locally, and it will list all the images available. So what I can do, I can run this particular image as a container. So what happens, a container would get created, and within the container the image would be executed. So this container will have X amount of processing capacity, X amount of memory, all that would be allocated, and all the dependent libraries will be packaged together within this particular image. So I don't need to do any other additional installation. I can map the network of the host system to the corresponding IP address. Say for example, Tomcat might be serving in the port 8080, and I may have another instance of Tomcat that will be running in port 8080 or 8081 for that specific container. So container acts like a virtual machine with n number of configurations pre-built, so that it can be started instantaneously and get the services up and running. I can map this port corresponding to the host ports. I can say the 8080 of this particular machine or this particular container will be interacting with the port, say 80, and the 8081 of the other container might be interacting with this particular port, say 81. And assume some other application, it is in need of a MySQL services. What I can do, I can download this particular image into this particular host and start a container and get that particular image up and running. So within no time, I should be in a position to get the image, get that particular image deployed as a part of the container and get that up and running. And I don't need to worry about finding the dependent library versions, get that installed, configure, and in the same machine I can have different versions of containers. Simple example, I may have two containers of MySQL with different versions. With the image, I can deploy different versions of MySQL. One could be a version, say 5, and other could be of version 8. This is what we call it as container orchestration, where Docker is a very popular one. And within Docker, we have another option called Docker Compose. So what I may have to bring in n number of components. Let's take another example. Assume I am going to develop a web application, so I need a web server. So I may need a web server, say Apache, and I may need a MongoDB, and I may need the React components or this could be an express. So I may need to deploy n number of components. So what I can have something called Docker Compose. I'll be providing a YAML file. It's yet another markup language where I will put in all the dependencies, what is going to be the name of the container, at what port it's going to serve that particular service, and what are all the dependent services. All the 3 containers would get downloaded and it would get executed in a different container. So the Docker Compose is going to facilitate us to deploy various containers in a single go.